All right, this setup here is one of the experiments that was done in the 1700s. It is these people who are trying to quantify for the first time what happens to matter when you change it from one form to another. So if some very smart person notices that if you take a battery, and the battery was invented in the 1700s by a guy named Voltaire, maybe you've heard of like him sticking things into frog legs and having them kick, that whole thing, he makes a battery. So somebody says, well gosh, what would happen if I stuck a battery into water? And so they stick a battery into water, and I've got this hooked up to pretty daggone high voltage. Except it should be like 200. Why are we not getting much voltage here?
It's climbing.
I guess it's climbing. That's very weird. Anyhow, we've got a huge amount of voltage here. And what do you guys notice, particularly the ones up front?
Bubbles. They're steaming.
There are bubbles. Steaming is a conclusion. Let's be really careful when we observe things. A direct observation would be that there are bubbles. An inference would be that steam is being made. So what are we observing? There are bubbles forming. That's not an observation.
Wait, is
right?
seeing that there's steam
So,
an observation?
no, because steam is what?
Water.
It is water vapor. That's not an observation. That is a conclusion. You have jumped directly from bubbles to steam. That's not an observation. You see what I'm saying? The observation is there are bubbles forming on both electrodes. A conclusion is that there's steam forming. Another conclusion is that there is hydrogen forming. Those are separate conclusions, right? But there's definitely...
gas.
Yes, but that's not what you said. That's my point. All right, so we're going to let this sit for quite a while, and we'll come back to this at the end of the class. We're going to let it go. But this is one of the experiments that people did. We'll talk about that later. All right, so what happened here? Observations is what we're going for here.
There's less water.
There is less water where?
In those tubes.
In the tubes. There is less water in the tubes, right? So the level of water has gone down. Good. What other observations?
There's some white stuff on that tube.
There is some white stuff on the tube. That's bubbles that are there. Other observations?
It stopped bubbling.
It has stopped bubbling. I turned it off. Yeah. Good. You're right. Other observations? One key one that no one said yet.
There's more air in...
There's more something in this one than in this one, right? And so people took stuff like this and they noticed something very striking. Not only is there more here, but if you quantify this, there is twice as much here as there is there. If you there's exactly twice as much of this as there is there. And it's a gas. And let me throw two more things at you, and I can't do these. We're not set up to do these, but they are this. If I take this gas and I put a flame next to it, it goes like that. It makes a big pop. It's a little bit like what you saw in the movie. If I take this gas and I put a flame next to it, it makes the flame bigger. It doesn't pop, but it makes the flame bigger. So is any guesses what would make a flame bigger? What gas does that?
Bigger would be like oxygen.
Oxygen. What gas is combustible?
Hydrogen.
Hydrogen. So nobody knows anything about atoms at this point, but they do know that if they take this and split it up, there's twice as much of this as this. And this, which they call, what did he call this? He called this combustible air or something like this. And this they called vital air. He knows that there's a 2-to-1 ratio. Wow, that's really cool, right? That's interesting. What could account for that? Well, nobody really knows at the time. But let me ask you guys. Suppose that I took hydrogen peroxide, which is not H2O, but H2O2. Give me a hypothesis. If then because.
There'd be the same.
You want to try it?
Oh yeah, if you did the same thing with hydrogen peroxide, then the amount of gas in both would be the same, since there's an equal amount of atoms in each, or equal amount of
Hydrogen's full.
People buy that? That's a pretty good hypothesis. Unfortunately, things tend to blow up when we electrolyze.